Okay, so let's begin looking at solutions to chemistry test number 1. Previously we had looked at questions 1 through 5, so let's just pick up with question 6. Question 6 asks us to identify a carboxylic acid functional group. And so let's do a quick review of not only the carboxylic acid functional group, but just some of the others as well. So a carboxylic acid functional group will have some R group, where R is just really any organic compound, and it will be making a covalent bond to a carbonyl carbon. So remember, a carbonyl is a family of functional groups. So we'll have a carbon-oxygen double bond, and then a carbon-OH single bond. This is a carboxylic acid. For example, gamma amino butyric acid is a very important neurotransmitter. And just to remind you, this is the alpha carbon, the beta carbon, the gamma carbon. So gamma amino, so we'll have an amine group. Butyric acid, or GABA. This comprises a carboxylic acid functional group. Some others to look for: if I simply have a carbon, oxygen, hydrogen bond, this of course is an alcohol. If I have a carbonyl that is bonded to two other R groups, and I'm not going to commit to those, that's why I'm truncating them. This, of course, is called a ketone. If one of those R groups is a hydrogen, I'm going to go ahead and draw that. This is an aldehyde. We'll have a lot to say about some of these functional groups as we go along, but this certainly is a nice start. So the carboxylic acid functional group in terms of answering question number 6 is certainly going to be answer choice C. So answer choice C will be the credited response. Let's look at number 7. We have a gas sample that occupies a volume of 400 milliliters at 760 millimeters of mercury and 25 degrees Celsius. The volume of the gas is decreased by a factor of 2. The temperature remains at 25 degrees Celsius. What will the pressure become? Look, you can do combined gas law on this, and let's just go ahead and do this the long way, and then I'm going to show you the shortcut version of doing this as well. So if you want to be hard-headed and do this the inefficient way, then you can simply use P1 V1 over T1 equals P2 V2 over T2. This is the combined gas law. The temperatures do not change. In other words, this is an isothermal process. And in an isothermal process, the combined gas law actually decomposes algebraically to give Boyle's law. Boyle's law is P1V1 equals P2V2, which means that pressure and volume are inversely proportional. Now, let's go back and look at the initial question, if you will. We have a volume of 400 milliliters and a pressure of 760 millimeters of mercury, and then the volume is going to be halved. So I could go ahead and take those values, 400 milliliters times 760 millimeters of mercury is equal to 200 milliliters times P2, and that's the variable that we're solving for in this particular problem. So I'm going to divide both sides by 200. Of course, 400 over 200 is going to be 2. 2 times 760 is 1,520 millimeters of mercury. 1520 torr. 2 atmospheres, if you will. But if we look at the problem more carefully, we didn't have to go through all of this detail, because if the temperature doesn't change, pressure and volume are inversely proportional. If volume goes down by a factor of 2, pressure must go up by a factor of 2. So A and D are exactly the same answer. I've just changed the unit. C decreases the pressure. Only B makes any sense to pick. And so for number 7, the credited response is B. Okay, so let's move on to number 8. Here we have an organic question. When water adds to a double bond, the type of bond that is broken is... We're obviously referring to electrophilic addition. We are breaking a pi bond to make 2 new sigma bonds. Let's look at that in just a little bit of detail. So my electrophilic atom is going to be the hydrogen in the context of water. And this reaction does come with the rearrangement, but let's just suspend the rules of rearrangement for just a moment. I have a carbon-carbon double bond, and one of the carbons gets the hydrogen. Remember, we have a proton transfer. And the other carbon gets the OH. This is, of course, in the absence of rearrangement. I add the elements of H and OH across a double bond. So I break a pi bond. And I make 2 sigma bonds. So to answer this question most directly, number 8, the answer will be C. I break a pi bond and make 2 sigma bonds. By the way, delta and ortho are absolutely nonsensical terms. Never pick those in a multiple choice question on your Pcat. Number 9. 1 gram of substance occupies a volume of 100 milliliters, and 4 grams of the same substance occupies a volume of 400 milliliters. Then the substance is most likely to be solid, liquid, gas, or plasma. So we have 1 gram of substance that has a volume of 100 mils, and then 4 times the mass has 4 times the volume. In other words, we're not expanding, we're not compressing, the density is relatively constant. I think we can automatically eliminate C and D because those densities are going to be very, very small and they're going to be compressible. So we come down to solid and we come down to liquid. My money is on solid being the credited answer because there's absolutely zero sign of any compressibility. So I'm going to choose A for number 9. Moving on to number 10. Radiation and penetrating power. The electron is going to have the least amount of penetrating power. Certainly, if you have gamma radiation, you become the Hulk or you just die. X-rays, we all know how they protect us against X-rays when we go to the doctor's office. They throw some lead over our nads and jolt out of the room before they shoot the X-ray. That's got to make you feel good about humanity. And then it's alpha radiation, which is doubly ionized helium nucleus, or beta. Alpha is more penetrating than beta. So that's almost a trivial question at this point. The best answer for number 10 is going to be B. Let's look at number 11. Toluene is an organic solvent and it is nonpolar. Notice that ammonia, water, and methanol are all capable of hydrogen bonding. They're all polar solvents. Like dissolves like. Let's take a moment and look at this further. So toluene, and I think it's a good idea to understand the molecular structure of toluene. All toluene is really is methylbenzene. C6H6 is actually benzene. If you know these structures, it's an absolute home run. They're unbelievably structurally similar to one another. So toluene will be most soluble in benzene. Toluene is the active ingredient in airplane model glue. So if I had to venture, Gus is probably huffing some toluene about this moment right now. And of course this is benzene. Very soluble in one another. So the answer for number 11 should be D. Number 12, if there are 3 electrons in 2p, the electrons will differ in, well, they're going to differ in the mathematical number of the magnetic quantum number. So they'll both be in the same shell, so n is equal to 2. They're p orbitals, so the L is equal to 1. But one electron will have a magnetic quantum number of -1, another one will have one of 0, the other one will have one of +1. This is just a fancy way of saying that these 3 electrons have the same energy level, the same orbital shape, but the orientations of these 3 electrons in terms of their p orbitals will be very different. One's a 2px, one's a 2py. and one's a 2pz, which means it's going to come out at you, and one lobe is going to go away from you. So the orientation will be different. So the credited response will be C. The magnetic quantum number will be different. Number 13 is about radioactive decay. And so let's just take a quick look at this reaction. We have monatomic nitrogen atom that is produced from monatomic carbon atom, and I produce an electron. I know I have to produce an electron because I have to conserve the number of protons. And so an electron is like an anti-proton. 7 minus 1 equals 6. This is called a beta particle. So all a beta particle is another name for an electron. This is called beta decay. When I take a neutron and break it down into a proton and an electron. So the number of nucleons stays the same. That's the sum of the number of protons and the number of neutrons. But the number of protons increases. So in beta decay, you have the same atomic mass, but you have a different number of protons. So that's a transmutation reaction, which means you change the nature of that element from carbon-14 to nitrogen-14. And so the best answer for number 13 is B, beta decay. Let's look at determining if molecules are aromatic or not. Very quickly, you have to have a number of pi electrons that once you set equal to 4n plus 2, n is an integer. So A should be eliminated because it has 4 pi electrons. And of course, we talked about this in class, where if you draw a Frost diagram of cyclobutadiene, and remember, we want to draw the Frost circle such that the apex of the ring intersects the circle, and each of these points of intersection is a molecular orbital. So there are 2 pi electrons. That's 4, there are 2 pi bonds, which means you have 4 pi electrons, which means you have 2 bonding molecular orbitals, 2 anti-bonding molecular orbitals. The way that this breaks down is you have 2, and then you have a half-filled HOMO. A half-filled HOMO is anti-aromatic. Highest occupied molecular orbital. This will be anti-aromatic. So this should definitely be eliminated from our contenders. And then quite honestly, this question is not too awfully difficult. You cannot pick C or D because you have sp3 hybridized atoms. C has 4 sp3 hybridized atoms. D has 1, 2, 3, 4, 5, 6, 7, 8 sp3 hybridized atoms. These disrupt the conjugation of a pi system, and so these cannot be aromatic. B is naphthalene. First of all, there are 10 pi electrons. If I set 10 equal to 4n plus 2, n equals 2, which is an integer, which means this is a Huckel number of electrons. Finally, we have 2 others to go. Number 15, the maximum number of double bonds that a CnH2n type of molecule can have is absolutely 1, because the formula for an alkane is CnH2n plus 2. I've lost 2 hydrogens. I use that to make a double bond. Now, it could be a ring, so it's asking me for the maximum number of double bonds. I can't have more than 1, so B is my answer. Finally, looking at number 16, we have a precipitation reaction, but let's look at the oxidation numbers carefully. They're not changing, so I have nitrate before, nitrate after. I have silver ion before, silver ion after. I have sodium ion before, sodium ion after. I have chloride ion before, chloride ion after. The only thing that changes is solubility. This is a precipitation reaction, which is a specialized type of double displacement reaction. The best answer is D. So I'm going to stop this particular video at this point. So we've now covered the first 16 solutions to chemistry test number 1, and I will continue with these solutions on another video.